16 asks, non-competitive inhibitors bind to the, so there's two different types of inhibition when we're looking at our enzymes. There's going to be competitive and non-competitive. So if we look at competitive inhibition to start, so let's say we have our enzyme here, and this sort of circular bit is the active site. So when the substrate comes in, it comes in this way, it'll attach like this, and that's what's going to cause the enzymatic reaction. So this is what typically happens. If there is competitive inhibition, for example, you will have your enzyme, this will be the substrate, and you will have an inhibitor which will be the exact same shape. However, it will basically block the active site from another substrate coming in. So this will basically be competitive, it'll come in, it'll sit here and it won't move, and therefore the enzymatic reaction can't happen because our substrate can't come in. If we're looking at non-competitive inhibition, so they're not actually being competitive with each other, so we have our substrate here and our enzyme here. Non-competitive inhibition means it's not binding to the active site, it's binding somewhere else. So if we take our same little, let's do purple for example, for a non-competitive inhibitor, it won't bind here, it'll bind to another site anywhere on the enzyme, so let's just say it binds here, and it'll basically change the shape of our enzyme. So now our enzyme will kind of look like this. It'll have a weird active site because it has a non-competitive inhibitor, and so now our substrate still can't go in. Okay, so this is what's known as the allosteric site. So this is the active site, and any site around it, sort of on the enzyme that's not the active site, is known as the allosteric site. So 16 is going to be allosteric site. So our non-competitive inhibitor isn't going to competitively bind to the exact spot the substrate wants to go. It'll bind somewhere else to change the shape, and that will then block and inhibit the reaction. So 16 is going to be C.